We were discussing about electrochemical series, and in that electrochemical series we have mentioned that you must have seen that depending on that series, choosing any two metals, if you are arranging them in electrochemical cell, one can be able to say that between the two metals which will be oxidized and which will be reduced. The question is, we from the electrochemical series we can easily choose. Looking at the position of the metals, if it is above it will be reduced, and if it is below it will be oxidized. So if those two metals were taken in an electrode, in an electrochemical cell, we are in a position to say which one will be anode and which one will be cathode. But the point is, the basis of electrochemical cell is under this condition. The concentration was 1 molar solution and the temperature was 298 Kelvin. But in all the cases, in all the electrochemical cells, these constraints or these the parameters will not be maintained. It will not be in standard state always. So in that case, there can be the change in electrode potential. So to deal with that, we are going to discuss today dependence of electrode potential on concentration. If we change the concentration and if we change the temperature also, the electrode potential will be changing, because the electrode potential or the reduction potential values that were given in the electrochemical series were in standard state. So if it is not in standard state, what is going to be the situation? To find it out, a scientist known as Nernst has given one equation known as Nernst equation. So today we are going to read the Nernst equation and the dependence of electrode potential on concentration. This equation will be dealing with those factors. If those parameters changes, how the electrode potential is going to be changed. Now I have divided this video into two halves. One is to deal with this particular concept, Nernst equation, and then we are going to solve numericals, because as I have told, these chapters, solid state, solution, electrochemistry, next chapter, chemical kinetics, full of numericals. We cannot escape from that. So let us see. So let us see a simple equation. Suppose metal, it is in cationic state, it accepts n number of electron and gives rise to M. So this is the main equation that we are dealing with. Now here, if it is not in standard state, if we need to find out, suppose E0 of Mn plus by M is already known. But what we have to calculate? Not E0. We have to calculate E of Mn plus by M. That we have to calculate, that we don't know. I hope you have understood. There is a difference between the two. It is in standard state, it is in non-standard state or in the given state. Now Nernst has proposed one equation regarding that. I am just writing it down. It will look like this: E of M n plus by M is equal to E0 of Mn plus by M minus RT by NF Ln by this reduced species of the product side M. Remember, it is in aqueous condition and it is in solid condition for this particular case. So it is solid and this one is okay. So this is the main Nernst equation. Writing equation number 1. But as we know, we can convert the ln to log for the simplification of the calculation, and we are just doing that. So we are writing E of M n plus by M is equal to E0 of n plus by n minus, we know to remove ln, and if we have to insert log, we should be writing 2.303 RT by NF log of this by that. Furthermore, just check this part. Check this part. R, it is the molar gas constant. The value is known already, 8.314. N is the number of electron. N, what is N? It is the number of electron transferred. And F is the Faraday. So if we want to calculate this value, this part separately, we know all these values, right? So if you want to calculate this value including 2.303, you can check it here. It will be 2.303 into 8.314 into T, that is temperature in Kelvin scale. Here is 25 degrees Celsius, so it is 298 Kelvin divided by 96,500. If you calculate this part, you can do it by yourself also. You will be getting this value, you will be getting 0.059. So as a matter of fact, we can rewrite this equation as E of mn plus by m is equal to E0 of mn plus by m, this value is known, minus 0.059 by n log of 1 by m of n plus, because the concentration of the solid part is taken as an unity. So this is our desired final equation, which is known as Nernst equation. Just highlighting this. I hope it is understood. Here you can see, very interestingly, the concentration of the solution is important. Temperature has already been inserted. So concentration and the electrode potential at standard state, both are playing the roles. If you change the concentration, this ultimate value of E cell is going to be changing. So this is how it looks like. This is the very well known Nernst equation. You write it down. I hope you have understood. This equation will be utilized to solve thousands of numericals. This is a separate part, okay? So this equation will be utilized from here on. Today itself we are going to do shortly. So write it down carefully, and most importantly, you have to understand what is the meaning of this equation. What is there and what is their roles. Write it down. Now let us solve few problems. So firstly I will write down the questions and then the answers. Question is, your job will be, after writing down the question, you pause the video, try to solve. If you cannot, then only see the answer. Question is, what will be the spontaneous reaction when the following half reactions are combined. The reactions are, first reaction is Fe3 plus accepting electron giving rise to Fe2 plus. E0 value is given, which is 0.77 volt. And the second reaction is MnO4 minus plus 8H plus plus 5 electron giving rise to Mn2 plus 4H2O. E0 value is 1.49 volt. Question is very clear. What will be the spontaneous reaction when the following half reactions are combined? And at the same point of time, there is an additional question. What is the E0 of cell? Remember, E0 of cell. So let us see if the informations are already being given and E0 values are also given. Our job is to first check that whether these will be the half reaction as it is or it will be changed, because both of them are positive values. And if I compare both the positive values, carefully see, if I compare both the positive values, this is greater, this one is greater. So if this one is greater, this electrode, manganese electrode, will be acting as a cathode. So this reaction will be as it is because it will accept electron. But as it is lesser, so we can expect, we have to expect, because here the reduction occurs, the oxidation must take place here because it is less. This is the main concept. So I have to rewrite the equation by reverting them. So I will be writing MnO4 minus plus 8H plus 5 electron giving rise to Mn2 plus 4H2O. And E0 value is also known, will be remaining as, remember, it is 1.49, just to remember. This one will be opposite. Why opposite? I have just told you. So it will be Fe2 plus giving rise to Fe3 plus electron. Next job is to balance the electrons. So to do that, it is very clear that here it is 1 electron and here it is 5. So it is to be multiplied with 5, it is to be multiplied with 1. So without rewrite, or let us rewrite rather, I hope you can understand from here itself. So I have to multiply this one by 5, this one by 1. So if it is multiplied by 1, it will remain as it is. Multiplied by 5, so this and this one. Okay, up to now? Why it is multiplied by 5, is it clear? Now, simply do this. MnO4 minus plus 8H plus 5 Fe2 plus giving rise to Mn2 plus 4H2O plus 5 Fe3 plus. This is the spontaneous reaction, the answer which we were looking for. I hope you have understood the process. Next is, we have to find out the E cell. E0 of cell is nothing but E0 of R minus E0 of L. R means cathode. On cathode side, which one is there? On cathode side, the greater one, that means 1.49, that is 1.49 minus. So we have written down these two values. Remember, it was 0.77 volt, but it is acting as an anode. So this is the final equation, and to get the E0 of cell, we will be doing E0R minus E0L. That is cathode, which is 1.49 volt, minus anode, which is 0.77 volt. Now you see how much it is. It is 2, I think, and it is 0.72 I am getting. Yes, it is. So it is 0.72 volt. That is the E0 of cell. So this is how we will deal with this type of problems. So the next problem for today is similar one. Question is, in a simple electrochemical cell, which is in the standard state, which is in the standard state, half reactions with their appropriate reduction potentials, half reactions with their reduction potentials are, these two are given, like one is Pb 2 plus Aq is aqueous, 2 electron giving rise to lead, which is solid. E0 value is given as minus 0.13 volt. This is E0 value, mind you. Okay, so minus 0.13 volt. This one. First equation. The second one is silver plus Aq plus electron giving rise to silver. E0 is equal to, simply we can write, is like 0.80 volt. Two questions are there. First question is, what is the cell reaction for the cell? What is the cell reaction? And second one is, calculate the EMF of the cell. So let us solve. First thing first, two things are written. Clearly it is visible that it is larger. So this should be cathode. So the opposite one should be anode. So accordingly we must be writing. So we should be writing as an answer, we should be writing Ag plus electron giving rise to Ag. And this should be written in opposite way, that is Pb giving rise to Pb2 plus 2 electron. And the values are known already. I am not rewriting. And as a matter of fact, we have to, next job is to balance the electrons. So it is to be multiplied by 2, and it is to be multiplied by 1. Result, Ag, 2Ag plus 2 electron giving rise to 2Ag, whereas Pb giving rise to Pb2 plus 2 electron. The answer should be 2Ag plus Pb. Electrons are cancelled out. Ag plus Pb2 plus. So this is the overall reaction. So we are getting the first answer. Second is EMF. So calculation of EMF means E of cell, and it is in standard state, so no need to check the Nernst equation. So it should be E0 of R minus E0 of L. So it is very clear, E0 of R means cathode, that is Ag plus by Ag, minus E0 of L means this part, which is lead 2 plus by lead. So it should be how much? This is 0.80 minus how much it is? 0.13 volt. So we'll be getting, I think, 0.93 volt. So this is the case. We have got both the answers, EMF of the cell and the cell reaction. So this is our second problem. Now we are going to check one or two problems related to Nernst equation. Now let us face few problems related to the Nernst equation. So the third problem for today will be like this. Zinc rod is dipped in 0.1 molar solution of zinc sulfate. The salt is 95% dissociated at this dilution at 298 Kelvin. Calculate the electrode potential given that E0 of Zn2 plus by Zn is equal to minus 0.76 volt. So let us solve this. 95% dissociated. First of all, let us write down the reaction. Zinc sulfate, Zn2 plus by Zn, so it is very clear that the reaction will be like this. Zinc 2 plus accepts 2 electron, becomes 7. So this is the main equation. So according to the Nernst equation, we know E of Zn2 plus by Zn is equal to E0 of Zn2 plus by Zn minus 0.059 by N log of Zn by Zn2 plus. This is the main thing. Now, 2-3 things we have to be very careful about. That is, what is the value of N? N is 2. So we should be writing it as 2. Number 1. Number 2 is zinc solid. What is the concentration? 1. So here this concentration value should be 1 only. And this was 0.1. 0.1 molar was the concentration of Zn2 plus. But it is 95% dissociated. So it should be actually 0.1 into 95 by 100. That is the actual value of Zn2 plus, isn't it? So it should be 0.095. Now you put these values. So this should be E of E cell, we can say. It should be E0 of cell is given minus 0.76 minus this is 0.059 by 2 log of 1 by 0.095. This will be the final situation. Now in this type of problems, we have to deal with these log values. So all of you learn how to see the log tables within one day. I think it is known by everyone, but still you will look into that, because this chapter and the next chapter, log related problems we have to solve. So I have done it previously, I have calculated it separately. So as a matter of fact, if you calculate this total part, you will be getting as, but you should do it separately, okay? minus 0.76 minus, it is getting us 0.03. Remember, I have done it separately before showing you this numerical, because these simple calculations I don't want to do it in whiteboard itself. You do it separately. This is not the chemistry part, this is the numerical calculations only, which you all of you should be able to do. So I'm not doing it. This we are getting as 0.03. Now as a result, we should be able to write it is minus 0.79 volt. So this is the answer. Next one, fourth one I think for today. The question is, if E0 for copper electrode is 0.34 volt, how will you calculate EMF value when solution is in contact with, when solution is in contact with 0.1 molar copper 2 plus ions. Now let us calculate this. So first of all, copper 2 plus ions, copper electrode, it's a copper electrode, and the solution is copper 2 plus ion. So we can expect that it should be like this, copper 2 plus 2 electron giving rise to copper. This should be aqueous, and this is copper electrode, so it must be solid. I hope it is clear. So let us write down the Nernst equation. It should be E is equal to E0 minus 0.059 by N. Directly we are writing to log of copper divided by copper 2 plus solution. We all know this value is 1 only, and this value is also given. So first thing first, we will write it like this only. In the next line, we can write E is equal to E0. E0 value is also given 0.34 minus 0.059 by 2 log of 1 by 0.1, isn't it? 1 by 0.1, interestingly, is log 10, and we know that log 10 is equal to 1. So this part becomes 1. So it becomes 0.034 minus 0.059 by 2 into 1. So how much you are getting? It is 0.034 minus, if you take this value, it will be 0.0295. So the answer we are getting as 0.31 volt, is almost equal to 3. So it is 0.31 volt. This is the E cell value. So we have today we have calculated few problems: Nernst equation, spontaneity of reaction, which equation is to be, which will be the actual spontaneous equation based on two half equations. These problems we have faced. I'm asking you to solve similar problems from NCERT. Some problems are there already. So for the time being, these 4 problems you must recheck by yourself, and whenever we meet after this, we will be solving those problems, maybe in the live classroom, or maybe in the video. Anyway, check it, check the process, do practice it by yourself, then only the purpose will be fulfilled.